For a final example, we're going to look at the final type of cubic we can get, and that's one that has a triple root in it. So one that has a single factor cubed. Once again, to find the x-intercepts, and I'll try and get it right this time, we have to let y equal 0. So let's let that equal 0. So in this case, the only way for this thing to be equal to 0 is if x minus 1 equals 0, in which case x equals 1. So in this case, we've only got one intercept, one x-intercept. Now our y-intercept, once again, happens when x equals 0. So we're going to get y equals x minus 1 cubed, but I need to make that x as 0 because that's what I'm substituting in. So I'm getting minus 1 all cubed. Now, minus 1 squared would be positive 1 times another minus 1. I'm going to end up with minus 1. So that is my y-intercept. Now, in this particular case, it's a little bit difficult to know what to do. With cubes, so triple roots, we actually, at this location, it's going to do a little wiggle. Okay, so at this location, right on that point, the curve is actually completely flat there, but it needs to curve outwards like this. So this is actually what this graph will look like. So when you get a cube root, okay, when you get a triple root, you end up doing this kind of wiggle. It comes up, it flattens out, and then it keeps going in the same direction. If you looked at the kind of the right hand side of this, it actually looks like a concave up parabola, and the left hand side looks like part of a concave down parabola. So you just need to be aware that that's what happens when you get a triple root.